FAFSA says, okay, like, you make this much money in a year, well then you're expected to pay this much money for each of your kids' education. So, you make that much money, you have this many people in your house, you have blah, 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 here's how much you're expected to pay. It comes out, this is how much money you make, this is your income, this is what they call your expected family contribution. So this will be a number, and I don't know what that number comes out to be. Let's say that number comes out to be $15,000. Let's say the number comes out to be $5,000. If the number comes out to be $5,000, that means you will, by federal law, be required to pay no more than $5,000 for your education each year. If the FAFSA form tells you that your expected family contribution is $5,000, you will not pay more than $5,000 for college each year.
Because that's what my mom actually said. There's a chance we can get bills to not pay at all.
That's right.
And that there's a chance that we can even get money back.
That is correct. So if you, depending on how much money is made, this number could be really small, actually could be zero. And there are some people who are going to college for absolutely free because of the FAFSA program. It's the free application for federal student aid, federal meaning from the government in Washington. So, federal government. And if whatever this number comes out to be, if it's less than what IPFW costs, free money. Like, it's practically free money because you're not paying as much as what the normal bill is. Say the normal bill is $10,000 a year, you're going to pay $6,000. So, do you want to fill out the FAFSA form?
I would love to fill it.
Yes, you would love to, because it's going to make sure that you are not paying more than you can afford. And that's a good thing.
Is that for any college or just after?
No. This is federal, so this is every college in the country. Yeah. The only college, and that, now, I don't want to say every, there's one college I'm aware of that doesn't take the FAFSA form in the whole country, and it's Hillsdale College in Michigan. And they're very anti-government up there. So, they try to function very privately, so they do not even recognize the FAFSA, but they're really unusual, really unusual. Yeah, I'm smiling because this Hillsdale kind of had, when I was applying to school, had this like stuck up impression, because they're like, we don't like the government, we don't take FAFSA forms. And we're this great school that's like this really tiny place that's all privately funded, blah, blah, blah. Their president of the university got caught in a adultery scandal with like 5 of his, yeah, 5 of his like secretaries. Yeah, it was scandalous. It was scandal. And so these people like came forward, and it's like this right-wing conservative, very like Christian like environment that like has this, you're head of your university, like yeah, so their image has suffered recently because of that. Once that's on Dateline, and Dateline, you know, that's easy, you're an easy target at that point. Yeah, if you're gonna play the, you know, conservative Christian card, don't be sleeping around with like 5 mistresses. Like I mean, it's really simple. I don't know, that's not a hard.
Like, how do women not know?
And if you're gonna get married too, don't like, that's it, you're done. Like, you're done with like the whole, you know, being a bachelor thing. Like you found someone to be with for the rest of your life. You're done. Game over. Like you move on to the next stage of life. So anyways, can anybody get FAFSA? Yes. Can it go to any school? Yes, except Hillsdale. Except Hillsdale. When I say something and it's not right, I try to retract my statement because it bothers me. So that's the only reason. I went into that much detail. But anyone, no matter what you make, come out, you come with a FAFSA number, and your expected family contribution could come out to be like $100,000. And if it did, you're not going to get money to go to any school. You're going to have to get money through other means, scholarships for great grades, or scholarships for great athletic abilities, or dance abilities, or whatever it may be. But offering insight, that's all. Did we have homework last night?
No, we did not.
We did not. Okay, so let me hand back the homework from the night prior. I might need 2 minutes here. Strange, actually, because yesterday whenever I was in class, there were 2 problems that I did that people missed some of them, kind of. Like there was one problem Yeah,
I
right?
know, we were grading them, we were like, wait a second.
Oh dear.
There was one problem that was like this, and the period was 2 pi, but it was a sine graph shifted to the right pi over 4 units. Hi.
Can I borrow you for one?
Sure.
She's great. Yeah.
That was the problem. Now, if it's shifted to the right pi over 4 units, like you guys went like this. Like, it's not shifted over 45 units. Like, if pi over 4 is what it's been shifted to, it's been shifted over that many units. Just use that, because the measure of the x-axis here is measured in pies. It's not measured in degrees, it's measured in pies. So, if you're right pi over 4, you're right pi over 4. If you're right 45, that's something completely different. Because pi over 4 is like 3.14, approximately. 3.14 divided by 4, which is like 0.8 something something something. Which is not 45. Right? Yeah?
When I saw pi, I thought of like 180.
Yeah, we do.
What is that?
I'm not saying you're wrong. I'm not saying pi over 4, because pi over 4 is 45 degrees. There's no doubt about that. But when it comes to the graph, how has this graph been shifted? The graph was shifted right pi over 4 units. Why has it been shifted pi over 4 units? Because that's the number of units it's been shifted over. I don't know how to say it anymore. Like if I take a absolute value graph and shift it 2 to the right, that's what I get. And is it shifted 2 to the right, or is, I mean, you could think, well, what if I shifted it, let's say, 45 to the right? I don't say y equals x minus pi over 4, because pi over 4 is like way over here on the axis. Because pi over 4 is like 0.9 or 0.8 something something. 3.14 divided by 4. It's going to be like 0.8, actually 0.7. 0.79 something something. So if you're right 0.79 units, you're not right 45 units, you're right 0.79 units. So that was a little detail, but the thing to look for is if the x-axis is scaled in terms of pies, any shift is going to be in terms of pies. If the x-axis is scaled in terms of degrees, the shift is going to be some number of degrees. If the axis is just scaled in terms of numbers, the shift is just going to be that many units. You probably overthought that, is what happened. And I think you're overthinking it, because when we tend to not understand something fully, we tend to overthink it. We tend to think it's more complicated than it actually is. But we find out when we do understand it is it's always simple. That's what happens when things get understood, is you find out that they're simple. So, this is not a big reproach, but I just want to make a point, because I'm certain that I never had that on the board. I'm certain that I only had this on the board. And it was strange to me. Because I heard some of you even say 45 pi over 4, and I'd say, yeah, 45 degrees pi over 4, good. Like, that's a good association to make, but it's not the proper thing to put into the problem, because if this is pi over 4, 45 is like way the heck away. Right? Think about that. And I know that I'm making a spectacle of this, but that's I'm just trying to bring home the point. If 0.79 is way over there, to get all the way up to 45, you're way here. And was the graph shifted this far? No. Yeah.
Wait, so how do we know when pi over a number is like 3.14 over a number, or when it's like 180 over?
See, this is an angle in terms of radians, and this is an angle in terms of degrees. Now, when we do these exercises, we're just asked to state the equation of the graph. So what you're supposed to do is look at the graph and say what the equation of the graph is. So this graph has been shifted right pi over 4 units, so we're going to use the graph principle of shift a graph right, plug in x minus that number. If you wanted to talk in terms of degrees, you could easily, instead of graphing a sine wave from 0 to 2 pi, you could graph it from 0 to 360. It would basically be the same thing, whether it goes from 0 to 360 or 0 to 2 pi. It just depends on how the particular person who was graphing that wanted to express it. Did they want to express the angle in terms of radians, or did they want to express the angle in terms of degrees? That's what it all relates to. If the axis is scaled in terms of degrees, you give all your information in terms of degrees. If the axis is scaled in terms of radians, you give the information in terms of radians. Because all we're doing in the graphing picture is just saying, okay, what's the graph? Give the equation. Well, if the graph is scaled in terms of radians, you're going to give the shift in terms of radians. If the graph is scaled in terms of degrees, you're going to give the shift in terms of degrees. However the graph is scaled is however the graph is scaled. Just adapt to that in a graphical situation. These kinds of circumstances where we actually make the shift are normally in like these problems when it's hard to imagine what 3 pi over 4 is. But it's easy to plug in 180 and figure out that that's sine of 135 degrees. Now it seems to have more meaning. That's when we go to degrees, is normally in these cases just to make it easier to process. So it was all I say is it was just strange because some of you lost, I mean, a half a point, which is not the end of the world, but it was a half a point on something that was done in class, so that was what was particularly unusual.
Oh, what are you talking about? I was like, I kept staring at that paper for like an hour. I'm like, no, I'm convinced it's on here somewhere.
I'm just stupid and skip them.
I'm like, I give up. I give up.
It's really
It was like,
I don't know.
And-
It's funny though, like, because like sometimes I want to like written down a few or something, I'll like read it with
I have to go up to the front desk and
Okay,
just let you know.
okay, thanks. Everything okay?
Robin needs to leave to pick up food for the ballet faculty.
Okay.
are you excited to wash the front desk?
Oh yeah, we're gonna have a party.
What is that?
I said, is she excited to wash
Nothing,
the
you're not
front
invited.
desk? He's sad.
You have classes.
Nothing, you're not invited.
A and B conversations see your way
I
out.
will see my way out.
Or what, it's a January and February conversation, you march your way on out.
Ooh, good one. I'm gonna use that.
Just kidding. That's funny.
I watched the best sports. I didn't have to do anything.
We're not bringing that one up. I'm in the coach class. I'm in the theater class. That's right.
Worst pickup lines ever. That was
Did it hurt when you fall from heaven? It's like, I don't like the stupid muscle guys are like, you got any tape? 'Cause I'm ripped. Or like, you got any tape? You got your ticket to the gun show? What? Anyway, circles and whatever they're called.
No, we're good, we're good. There's always time to find that. Okay, circles and using complete the square to graph.
Become fond of complete the square.
Yeah, I mean, it's not everybody's favorite thing to do, but fortunately, they give you real nice numbers to work with in these problems, so it's kind of easy. When we normally graph a square, what's the equation, or graph a circle, what's the equation for a circle?
I squared, that's what you could
R squared.
I squared, but I think
So-
say one.
I don't know.
This is like r in each direction centered at 0. And we know we could shift this some amount horizontally and some amount vertically as well, right? We could start shifting it. So this would have the center at HK. right, shift down, shift up, shift left. We could also change the radius accordingly, and so on. So what if we had something like this? What if we had the equation x squared plus y squared minus 6x plus 8y plus 21 is 0. Complete the square to graph the circle. I'm going to do some rearranging, and as soon as I do rearranging, I think it will be clear how we will complete the square. I'm going to take the x squared term and the minus 6x and put those next to each other, because that feels like it's ready to complete the square. I'm going to put the y squared term and 8y next to each other, and that's going to feel like I'm completing the square. I'm going to move the 21 to the other side, because the number in the circle equation always is on the right. So it's the x squared term on the left, the y squared term on the left, the number term on the right. Now, looking at this, what number completes this square? Take half the middle one and square it. That's going to be negative 3 squared. You're going to add 9, right? And if you add 9 on the right, you've got to add 9 on, excuse me, if you add 9 on the left, you've got to add 9 on the right to keep the equation balanced, right? Because if we put plus 9 on the one side, we've got to put plus 9 on the other side to make those line up. For the second one, half the middle one, positive 4, square it, plus 16. Add 16 to the right as well, because if we added 16 on the left, we're going to have to add 16 on the right to keep the equation balanced. Rewrite the left. You just completed a square, so you can now write it as x minus 3 squared. You just completed the square on the right as well, that's y plus 4 squared. And 21, negative 21 plus 25 is 4. So you should be able to graph this now. Where is the center at? Right 3, down 4, radius, 2, right? Okay, so right 3, down 4, radius is 2. So you go 2 in every direction, you're not going to cross any of the axes. And there's your graph. It is appropriate when graphing a circle to draw in a radius and put its radius length, just to verify that, because based on the picture, the radius could be anything between 0 and 3. We want to make sure that we say it exactly, just so that it's perfectly clear. But, I mean, that wasn't utterly impossible, right? Right? It's completing the square, but it's doable. I hope that's not really impossible. Okay, let's do another one. X squared plus y squared plus 4x minus 6y plus 6 equals 0. Complete the square to graph the circle. The nice thing about this too is the book will actually tell you what the graph is. It tells you it's a circle. So you're like, okay, you can groove your mind and think, okay, we got a circle, x squared plus y squared equals r squared. So you want your x's on the left, your y's on the left, your number on the right. So rearrange x squared plus 4x plus rearrange y squared minus 6y negative 6 on the other side. X terms, y terms on the left, number term on the right. Now we got a pair of squares to complete. Half the middle one, positive 2, square it, add 4. What you do to one side, you have to do to the other. Half the middle one is negative 3. square it, add 9. What you do to the one side, you've got to do to the other. X plus 2 squared, y minus 3 squared, and 7. So left 2, up 3, and the radius? If r squared is 7, yep, take the square root of both sides. R is square root 7. So let's draw the picture. Everything all right?
We were both getting ready to grab it, we just kind of looked at each other like, how do you know what square root 7 is?
Yeah, so if you're curious, go to a lower square root that you do know, square root 4, and go to a higher square root that you do know, square root 9, and that'll tell you it's between 2 and 3 units. Right? Right?
So it's just like,
Yeah, yeah. It's
shoot the second point. I did the same thing.
it's good. I mean, it's good to be curious about that because now the thing that we want to be careful about on this in this problem is if my radius is between 2 and 3 units, technically I'm going to have to go past the y-axis because it's only going to take 2 units to get to the y-axis. But technically I'm not going to go past the x-axis because it takes 3 units to get to the x-axis. Yes? Do you see that? So when you draw this, you're going to have to be careful because to draw this correctly, your circle should not cross the x-axis, but should cross the y. Like so. Again, notice the gap here to the axis is 2, where the gap here to the axis is 3. And 3 is longer than the radius, and 2 is shorter than the radius. The radius? Square root 7. Now, if you drew it like I did to where it doesn't look exactly circular, that's okay. Your center should be well labeled. Your radius should also be well labeled. You should be crossing the axes appropriately. The axes appropriately. But if you do that, you got it. And nice numbers. They give you nice numbers. So, I mean, it's more a chore than a challenge. At the same time, if you gave this to the average high school graduate and asked them to graph it, 1, they'd laugh at you. 2, if they didn't, whether they laughed at you or not, I would guess, this is my guess, I would guess that 1 in 10,000 high school students would actually be able to graph that. That's my suspicion.
How do you do it on the calculator? Like, do they just type that in and then it shows the graph?
Unfortunately, on the calculator, you can't, on certain versions of the calculator, you can't even make that graph. Because the graphs on the calculator have to be in the form y equals.
Mm-hmm.
And, right? So the closest you could get, would be to do this. Just subtract that term and then take the square root of both sides.
Brain power so much better.
And then you're going to have to subtract 4. It's going to be 4 minus x minus 3 quantity squared minus 4. And if you graph that, you'd only get half the circle. Because when you take the square root, you have to have a plus and a minus. So if you're going to put them in your calculator, in your y1, you put the positive portion. And in the y2, you have to put the negative portion. Yeah, so my short answer is there's not an easy way to put it on the graph. If you do put it on the graph, you're going to have parentheses inside your square root with the square as well, and it's going to be a disaster to put in the calculator. If you do get it in, the positive portion will be the top half of the circle, and the bottom portion will be the negative half of the circle. If you do get it in. You could try a simple one, like x squared plus y squared equals 1, like the unit circle. That would be. That's a one.
It's like seriously. Where's the 2?
That might be a simple one to start with. Olivia, you could start here. That would graph the top half of the unit circle.
I think I'm broken.
I think you're broken.
I
Hey,
think
you
I
did.
need to go away. I'm pressing the quit button.
I thought everyone's in the tree actually.
You might have to go quit,
Well, I think
there's a
I
quit button.
too. Or maybe I just didn't press record.
Okay, so for tonight, to get us through 63 here,
I want to shoot that.
1, 2, 5.
So I switched to 12 and 13. It was like 9 through 13. Oh, I don't feel like you're 9 through 13.
I don't know.
Her,
so from what, 63, 63, 9, 10, 12, 13, 17, 20 through 22. And 26.
We can have this, which numbers is in
I
15.
used to be really good at it.
Did we study in physics or math? We used to, I never really, someone used to do that with too. No, but no, she.
Oh, we did. I used to do it in geometry all the time. We used to
Or was
do
it-
that.
was it,
It was algebra.
we used to
Because we don't like drawing a number. Is physics gonna be just you and you too?
It's gonna be you, me,
Android.
no wait,
Hey, don't you think that physics is a lovely class?
I thought it was
What
fun.
did like Holly and Deanie and
Just go ahead.
Like the whole chemistry class.
basically did?
First and I'm like,
I just want to bring up a point here just for a second, because this is kind of a fun example just to discuss. But this is a problem that they give you in this section. It relates to a previous section, but it's problem 11. And it's ax plus by equals c and dx plus ey equals f. Now this is just like an algebra 1 problem. It would be like that, where a, b, c, d, e, f. Now the beauty of this is if we solve this problem, we'll have a formula that would solve every single substitution and elimination problem in all of algebra 1. Right? If you solve it once, you solved it in all cases. So here's how we do it, watch. I'll multiply the top one by negative e, and I'll multiply the bottom one by b. That's going to give me a negative eby and a positive eby. I'm just going to eliminate. You ready? Okay, so we'll get negative eax plus, or excuse me, minus eby equals minus ec. And below, we multiply by b, so we have bbx plus bey equals fb. Eby cancels. The x's are going to add together, and you're going to have bd minus ea x's. And over here, you're going to have fb minus ec. You solve out for x, you get fb minus ec over bd minus ea. This works every time. So if you look at the solution here for x, it'd be f times b minus e times c over b times d minus e times a. 12 plus 10 over 18 plus 4. If you look at this equation system, the solution is 1, 1. 2 plus 3 is 5, 6 minus 2 is 4. It worked.
Game over.
How cool is that, right? Every time it works. Now the thing that's really interesting about this that we're not going to get to talk about, but BD minus EA, if that was 0, what would your problem be? Unsolvable. So you could look at any system, take ED minus EA, and if you get 0, it's unsolvable. Immediately. Kind of cool, right?
does wonders.
We're like,
Yeah, okay, anyways, I'll leave you at that.
I love how most people are like, you guys are weird. I'm like, this is cool.
we're like, oh my gosh, this is so